On July 25, 2001, the residents of Changanacherry woke up and looked out their windows. The rain had come, but something was very wrong. The water falling from the sky was red, not slightly pink, not faintly tinted. Red, the same dark, heavy shade as blood. The clothes hanging on the clothesline were stained, the sidewalks soaked. The pots and buckets that families had placed outside to collect monsoon rainwater overflowed with blood-colored liquid. And then it stopped. It lasted less than 20 minutes. But it came back, and came back again. For nearly 2 months between July and September of 2001, red rain fell sporadically over dozens of localities in the Indian state of Kerala. Sometimes yellow, sometimes green or black, but mostly red. How can a sky bleed? Kerala lies at the far southwest tip of India, washed by the Arabian Sea. It is a green and humid land, swept by the monsoon. Its people know rain like few peoples in the world, but no one there had ever seen anything like it. In the hours before the first red rain, residents of Changanacherry, in the Kottayam district, reported a sonic boom accompanied by a flash in the sky, like thunder without a cloud, like something had cracked apart up above, and then the rain came. Red. In the days that followed, the trees in the region began shedding their leaves. The leaves fell gray and shriveled, as if they had been burned. Dry wells resurfaced. Others simply ran dry. Something had disturbed the environment, but what? Within days, scientists from the Center for Earth Science Studies, CESS, and the Tropical Botanic Garden and Research Institute, TBGRI, were already collecting samples. What they found inside every milliliter of red water was almost impossible to believe. 9 million solid particles. 9 million per milliliter. Over 2 months of rainfall, an estimated total of 50,000 kilograms of these particles fell across Kerala. If you want to keep discovering the strangest and most extreme places on Earth, subscribe to Dead Zones right now. New videos every week, and each one is stranger than the last. The scientists had a problem. Those particles didn't look like anything ordinary. The first hypothesis was a meteor. After all, there had been that boom, that flash. The CES even announced it could be dust from a meteoritic impact. It made sense, until they realized that meteor dust doesn't fall for 2 months over the same area, immune to wind, with surgical precision. They retracted the hypothesis within days. Others suggested desert dust. LiDAR observations, a laser radar system, detected a cloud of atmospheric material over Kerala in the days before the rains. But that theory also fell apart. Saharan dust doesn't explain the localized distribution, nor the intense color, nor 2 months of occurrence. A researcher from the Indian Meteorological Department put forward an even more creative theory: the eruption of the Mayon volcano in the Philippines, which was active at the time. He calculated that the equatorial jet stream could have carried volcanic material to Kerala in 25 to 36 hours. Plausible, until tests showed that the particles were neither acidic nor of volcanic origin. There were also those who proposed blood. Literally, blood. The theory was that a massive flock of bats had been destroyed at altitude, perhaps by a meteor, and the red blood cells had rained down over Kerala. But no one found wings, no bones, no bat fragments, and no natural process separates red blood cells from the rest of the blood while airborne. With every theory that died, the mystery grew. Then the researchers looked more closely, with microscopes, with laboratory cultures, with patience. In November 2001, the report commissioned by the Indian government's Department of Science and Technology reached a startling conclusion. The red particles were spores. Spores from an algae, specifically spores of Trentipolia annulata, a microorganism belonging to the green algae group, but which appears in intense orange and red tones. This is because it produces pigments called carotenoids in large quantities, which completely mask the green chlorophyll. The algae is, literally, a green algae that looks red. And where did it live? On tree branches, on rocks, on walls, on the bark of utility poles in the Changanacherry region. When researchers returned to the site in August 2001, They discovered that almost every surface in the area, every trunk, every walk, every wall was covered in Trentipolia, in quantities sufficient to generate each of the 50,000 kilograms of spores that rained down over Kerala. The solution seemed simple, but there was a problem, a big problem. In 2013, a molecular genomics analysis revealed that the spores found in the 2001 rains did not belong to any species native to India. The Trentipolia annulata found in Kerala was genetically identical to a variety found in Austria, Europe. Spores from a European algae had crossed the entire Indian Ocean, swept by clouds over the Arabian Sea, and fallen on Kerala. Think about that for a moment. An algae growing on a rock in Austria released its spores. The wind carried them into the clouds. The clouds drifted for thousands of kilometers, and they fell on an Indian city as blood rain. This is not science fiction. This is planet Earth functioning, and we barely had any idea this was even possible. To understand what happened in Kerala, you need to understand two phenomena that rarely appear together: the biology of spores and the mechanics of the atmosphere. Trentipolia spores are extraordinarily resilient. They measure between 4 and 10 micrometers, thinner than a human hair. They are encased in cell walls so dense that they withstand ultraviolet radiation, extreme desiccation, drastic temperature variations, and even most chemical agents. They are essentially a seed designed to survive in space, or at least in the upper atmosphere. When the monsoon reaches Kerala, it does so with violence. Wind shear currents and thermal convection eddies can tear biological material from treetops and hurl it into the upper troposphere. There, it mixes with water droplets that will form clouds. But the Trentipolia that fell on Kerala came from farther away. It came through the Intertropical Convergence Zone, the ITCZ, an equatorial belt where northern and southern winds meet, creating vertical and horizontal air currents of continental scale. Kerala sits right there, at approximately 8 degrees north, within the zone where this system operates. And the species found, not native to India, had to cross the Indian Ocean aboard clouds. This is a phenomenon that has a name: intercontinental dispersal by clouds. Previously documented in bacteria and fungi, the 2001 Kerala rain was the first time this mechanism was confirmed for an algae. The sky is not an empty space. It is a biological highway. The red rain of Kerala sparked a scientific controversy that still echoes today. In 2006, two physicists from Mahatma Gandhi University, Godfrey Louis and Santosh Kumar, published a paper in the journal Astrophysics and Space Science, proposing that the particles were of extraterrestrial origin, remnants of a comet that had fragmented in the atmosphere above Kerala, releasing living cells into the air. The scientific community was skeptical. Louis and Kumar's initial tests indicated the absence of DNA, which they used as an argument for extraterrestrial origin, since beings from other planets might have a different biochemistry. But later tests, carried out with more refined techniques, detected DNA perfectly compatible with terrestrial organisms. The panspermia theory applied to Kerala was dismissed by scientific consensus. What remained, however, was something more lasting: proof that Earth's atmosphere is a vehicle for biological dispersal on an intercontinental scale. Spores, bacteria, and fungi cross oceans inside clouds. They land in new territories. They colonize environments where they did not previously exist. And that has implications that go far beyond Kerala. If microorganisms can travel from continent to continent inside clouds on Earth, what does this mechanism tell us about the possibility of life migrating between neighboring planets? About how life may have spread across the early solar system? The blood rain of Kerala didn't answer the question, but it formulated a new one, far greater. Kerala remains the only place on Earth where recurring colored rains have been documented with scientific rigor. In 1896, 1957, 2001, 2006, 2007, 2008, and 2008, and 2012. Each time, the same Trentipolia annulata, carried in clouds from somewhere beyond the horizon. The sky still bleeds over Kerala, and science, at last, knows why, but still doesn't know exactly how. That's what I find most fascinating about this story. Sometimes the scientific answer doesn't close the mystery. It only deepens the question. If you've made it this far, you already know that this planet is stranger than any fiction. Subscribe to Dead Zones so you don't miss the next impossible place. And drop a comment below. Do you believe algae spores crossed an ocean, or do you prefer the comet theory?